Hello, this is Peter Newman. This video will look at some of the tools that are available to make it quick to build models. And I have a piece of geometry that we're going to open in SpaceClaim and do a little preparation work. This geometry came from CATIA, and when CATIA writes out step file, it splits cylinders up, so we're going to repair those. And here we have the geometry, and as you can see, the cylinders are split. Now we want to turn these cylinders into beams. So first we'll go to the repair tab, extra edges, check that off, and now all the cylinders are clean, and that'll let us go into the beam under the prepare tab and extract beams from these, and we'll just draw a line through all the beams, and now they are beams with the correct cross-sectional properties. So this is what we want to bring into mechanical now, and we'll see some productivity tools to build the mesh. And I'll fire up mechanical, and I'll pause the video while it starts. Okay, and now mechanical has brought that geometry in, and what we want to do is we want to bond the tops of the beams to the holes that they poke through. And so a quick way to do that is to click a hole with the edge filter. So we pick a hole, and then we do a named selection and call that top holes, and we apply that to the same size at the X location, and we have now a named selection with 35 edges. We'll do the same for the bottom holes. We'll do pick that and hit the N key for named selection and call them bottom holes, and they're the same type in X location. So now we've got those. What we want is to stare down this thing and grab with the box select tool. We want to grab all of the let's make sure we've got them all. We want to grab all of the vertices, and I need to pick the vertex filter. So here's all the vertices on the top, and that's a named selection, top beams. And we're going to grab all of the bottom beams and N for named selection. So with that, we can go into the connections folder and insert a manual contact, and we'll do that using named selection. And the contact, I think, needs to be the beam and the top holes. And there we have it. And then if we duplicate that, we want to do the same for the bottom. Duplicate is here on the list. And then we'll just do bottom beam and bottom holes. Now what we want is for both of these to have a pinball that's big enough to find that, and so maybe a 10mm pinball that will guarantee the contact finds the connection between the vertex and the hole, because the beams that end a little bit below the top of the plate. And we're going to also add some mesh controls. So we're going to insert, we're going to go back to single select here. There we go. We can now pick a face, and on this face we want to insert a inflation, and we want to inflate this with the all of the top holes, so the boundary is not by geometry but by named selection, and that's the top holes. And we will take the top holes, and we want that to be first layer thickness of 1 millimeter and just one layer, and we'll do the same for the bottom. So that is this face. We want to insert inflation on the bottom and use named selection bottom holes, and first layer thickness 1 millimeter and one layer. So now we can mesh, and it's not going to take too long to mesh. We'll see the results of our inflation. So here's the and you see you have a nice little 1 millimeter ring around each hole. So just to finish up the video, we'll go into the static structural, we'll pick an edge and we'll extend to limits, and we'll call that the fixed side, and then maybe on the other side here we'll pick a hole and we'll apply a force of 100 newtons to that hole, and maybe we'll flip that down. So let's apply, there's the force, and we might do a couple of things like turn auto time stepping on with 10 sub-steps, and we might turn large deflection on, and we're good to solve now. So we'll hit the solve button and come back in a moment to look at the results. I'll just pause the video while it's solving. Okay, I paused the video while it was solving, but I also will go back and show you what went wrong. But first I'll show you what went right, and that is to insert a defamation plot. Let's do directional for the x-axis and evaluate that, and then we can see the defamation, and if we want we can animate that. So we have a successful result. Guess we ended up pushing down in this direction. Now this result is after I made a change when the solution failed, and the change I made was to the contacts, and these two contacts have a pinball radius of 12. Earlier you saw me type in 10. That apparently wasn't large enough. 12 did the trick, although the difference between 12 and 10 looks like it should easily allow the vertex to grab the nodes around the circle, but apparently it failed, and I'll show that failing for you. I'll also just show you, as we click on the solution information window, click on geometry, you can see the little spider web of connection elements between the vertex and the edge of the hole and the first element outside, the first nodes outside the hole. That little spider web is the bonded contact. So let's forget this solution and go back and see what it looks like when something fails. So for these two things, I originally had 10 millimeters, and it was not MPC but program controlled. That was the original condition. And if I say solve, let's see if it repeats the failure that I had a moment ago. And we will click on solution information, and here it goes, and we get an error, and the error is an internal solution magnitude was exceeded, and so that means something wasn't connected. And if we insert, and you didn't see this also, but under the connection folders, if you insert a contact tool, which is what I've done here, and then you generate initial contact results, you will get a far open condition, and that means the bond is not connected, and that's why we had a failure on the on this. And so I'm going to go back to 12 millimeters and now evaluate the contact, and it still says far open, but for some reason it was successfully solving. So that's just a little bit of a mystery. Let's see if the formulation makes a difference. It shouldn't. Let me just get a fresh contact tool. Sometimes the contact tool, insert contact tool and generate initial results. I always use a contact tool if I'm using frictional contact, and here we see it closed. So it's always a good practice to insert a contact tool under connections folder and make sure your contacts are closed, and if they're not, then you use a pinball radius to get them from far open to closed, and that's what we did here with this pinball radius. So I hope that's been an informative video, and catch you next time. Thanks for watching. Bye.